In this video, we will use Vernier graphical analysis to create a best fit line for some data. So I'm going to go to a new experiment and manual entry, and I'm going to hit the 3 buttons. Maybe I'm not. There we go. Under column options, I'm going to give it a title. So let's call this time, and the units will be seconds. And then on the next one, column options, this will be position. And my units will be meters. Okay, then I'm going to enter some data. When we enter in graphical analysis, it goes to the side. So when I hit next, it goes to the side. Okay, so there's my data, and I can see that it makes a nice curve. One thing that I love about graphical analysis is that by tapping on each variable, I can choose what goes on that axis. So if I would like to swap my X and Y, I can do that really easily. Again, just by tapping and choosing the appropriate variable. Now, this data is not linear. I could choose to do, I could choose to do a linear fit, or I could try to do a linear fit. And you can see here pretty clearly that this linear fit is not appropriate because there's a pattern where the points are below the line in the middle and above the line on the ends. So I need to, I'm going to get rid of this. And in this case, I'm going to perform a calculated column. I'm going to call this column time squared. And in this class, we'll talk more about when and why you would want to do this kind of thing. But in this example, we'll just see how, we'll see how we can change and linearize or straighten out the data. So here I've got my, I've got a formula selected, and what this is going to do is it's going to take A is 1, so it's going to take 1 times X as my variable, that was time, and then the exponent is going to be 2. You can see here that X is time down at the bottom. So I'm going to add this calculated column, and we can see that time squared now is 1, 4, 9, 16, and so on. And it actually put time squared on the x-axis here for me. I can still make choices about which variable I want. If I decided I wanted to go back to time, I could do that. But for right now, I'd like to go to time squared. Now, to perform a linear regression, I'm going to touch the button in the lower left-hand corner. I'm going to hit Apply Curve Fit, and again, I can see what my slope and my y-intercept are. For this next part, I'm going to take a screenshot and use the markup tool, because in physics we always want to write our equation. Now it's tempting, you can see down here that it says y equals mx plus b, and that is true. Oops. The Apple Pencil is being fussy. One second. What I must do is on the y-axis I need to put the name of the variable and its position. Then I put the slope. The slope here is 0.997. M is slope. The units for the slope will be the y units, that's meters, over the x units, that's seconds squared. Okay, so that's my slope. Now I need my x variable, which was time squared, and then plus b, the y-intercept. The y-intercept here is 0.092, and the unit is meters. So this is my formula, and that is the proper way to write that formula. Notice I've got the variable names, position and time, and I've got values with units. The only other way that would be acceptable to write this is with the variable letters. So the letter for position is x. The variable for time is t. So I could write it this way, not writing the words out, but I must have the proper variables. I cannot have just x and y. I need to have, in physics, I always need to have my context, which are the names of my proper variables. All right. Again, that was a little tutorial on how to use graphical analysis to create a graph in a linear regression.